JEE asks simple mole concept questions, but students overthink and lose marks. Let's fix that today. In last lecture, we completed some important basic terms, what you should learn before going for numericals. If you did not watch that lecture, once you go through lecture 1, then come to lecture 2. Then, today we are going to start the mole concept basic numericals, most important for upcoming sessions. Let us start. So last class, what is mole? How to define mole? How we use mole? We completed. Let us move into basic important numericals. So here, how we calculate number of moles? See here, calculation of number of moles. Calculation of number of moles. See, in three ways we calculate number of moles: based on mass, based on volume, based on number. So how we calculate? Let us see one by one the calculation of number of moles. Method number 1. Here, calculation of number of moles. First method. Method number 1. See here, in method number 1. By using mass. So how we calculate number of moles by using mass? See here. So here number of moles is equal to, number of moles we can represent by using N. Number of moles is equal to given mass of the substance, whatever mass given in the question, given mass of the substance by atomic weight for atoms or molecular weight, which is expressed in grams here. You can say gram atomic weight or gram molecular weight of the given element, whether it is an atom form or molecular form. Based on that, we change it by using mass. Another formula, that is by using volume. By using volume. Next formula, purely based on volume. So what we do here, see, for volume. If volume of the substance is given, then here we use number of moles is equal to given volume of the substance. Given volume of the substance by volume of the gas at STP conditions. Volume of gas at STP conditions. Further, if you see here, volume of gas at STP, so STP we know 0 degrees Celsius and 1 bar pressure. So here, volume of any gas at STP conditions, 22.4 liters. Further, if I modify the formula, so given volume in liters we specify. As we know, 1 mole of any gas at STP conditions occupy 22.4 liters. Here I am taking 22.4 liters. So another formula, if volume based information is given. Third formula, calculation of number of moles if or you specify by using number. Here by using number of particles. By using number of particles, if number of particles information given, how we calculate number of moles? See here. Number of moles is equal to given number of molecules or atoms by Avogadro's number. Na refers to Avogadro's number. We know that Avogadro's number exactly equal to 6.022 into 10 power 23 particles. So here, overall if you see here formula, the first formula, number of moles is equal to given mass by molecular mass, molecular weight in grams. Formula number 1. Formula number 2, number of moles, small n, is equal to given volume by 22.4 liters at STP. Given volume by 22.4 liters at STP. This formula we consider only at STP. STP and TP we take it as synonyms. So both we consider as same. If number of particles information given, in such cases, what we specify here, number of moles is equal to given number by Avogadro's number. Here it is in liters. Here also volume is in liter. Third formula, given number by Avogadro's number. 90 to 95% of the questions in mole concept directly indirectly related to these three formulas. Directly indirectly related to these three formulas. If you are clear with these three types, easily you can do any type of question. See here. Now overall if I write together, W by M is equal to V by 22.4 liters at STP is equal to N by Avogadro's number. So here the most important formula, that is conversion, what we use in upcoming concepts. Very easy. Once if you know about these three, easily you can solve any type of question. Here if you observe previous, once everyone go through the formula, the interconversion of mass based, volume based, number based. Here there is one important term, or you can say terms, which grab the concentration of JEE. Most of the JEE questions, or you can say JEE loves these topics. Every time in every JEE exam, one or two, directly, indirectly, based on these terms, many times questions asked. What are those terms? See here. These are JEE favorite terms. What are those terms? Number of times repeatedly asked questions. What are those? Term number 1, gram atom. Term number 2, gram molecules, or you can say gram atom, gram ions. These three terms repeatedly asked in JEE exams, but where there is chance of confusion. Every time most of the students make mistakes in these three terms. Watch video with more concentration, because if they ask about calculate number of moles, easily can do. But if they ask question in twisted manner by using any of these terms, how to proceed for that? Let us see here. But in simple hack here, all these three terms similar to moles. All these three terms similar to moles. Meaning here, I can write 1 gram atoms. 1 gram atoms is nothing but 1 mole atoms. 1 gram molecules. 1 gram molecules, which is also referred as 1 mole molecules. Avoid confusion. Everything should be clear from here onwards. 1 gram ions meaning 1 mole ions. So here no difference. Only to twist question, they use this. So remember the important box where you need to pay attention. That's why I mentioned here JEE favorite terms here. Gram atoms, gram molecules, gram ions, because these are the terms which confuse students. Students make mistakes only because of these terms. Similar to moles, but how we can assess 1 gram atoms, 1 mole atoms, 1 gram molecules, 1 mole molecules, and so on. Similarly for ions. Anyway, you can use it. So let us enter into the numericals part after knowing about some important relations. Let us see. Question number 1. Question number 1. See everyone, once you see gram atoms, gram molecules, how we considered here, let us dive into the important basic numericals. Okay. Move further. First question. Calculate number of moles. Calculate number of moles in 3.2 grams of CH4. Number of moles in 3.2 grams of CH4. The question asked. So how we need to do? Here they gave about mass. They gave information in terms of mass. We know number of moles is equal to given mass by molecular mass. So given mass how much here? 3.2. Molecular mass 16. How? Even an exam they gave here, carbon is 12, hydrogen is 1. Sum of those atomic masses is equal to 16. So now 3.2 by 16. So how many moles we are getting here? 0.2 moles. 0.2 moles is answer. Simple question that is based on mass. Now, another question. See another question here. Here they gave calculate number of moles. Calculate number of moles in 70 grams of nitrogen. 70 grams of nitrogen. Focus on this term. Most of the students make mistake here. Nitrogen given. Confusion is whether we have to take N or N2. Whether to take 14 grams or 28 grams. So here no confusion. Clear cut, whenever nitrogen given, you should take only N2. 70 grams of nitrogen given, you should take only N2 because nitrogen exists in molecular form. See, calculation part. Number of moles is equal to W by M. So which is equal to 70 grams by 28 because it is nitrogen exists in N2 form. That's what we are writing 28. Overall here it is 2.5 moles. 2.5 moles. See, we are discussing basic important calculations. Slowly we are moving towards advanced level. But for that, you should be clear about these basic terms. Without these, directly if I go to advanced level question, no use. Every lecture should be followed to understand upcoming concepts. Next question. If I ask one question like this, 4.5 into 10 power 24. 4.5 into 10 power 24 molecules of ozone. 4.5 into 10 power 24 molecules of ozone given. And here we need to find number of moles. Find number of moles. So here it is molecule based. It is molecule based. So here we need to find moles. They gave information about number. So how we need to do? We know already. Number of moles is equal to N by Na. So 4.5 here it is given. 4.5 into 10 power 24 molecules given. Avogadro's number here we know 6.022 into 10 power 23. So here approximately you can say around 7.5 moles. 7.5 moles. Okay. 7.5 moles approximate we are getting here. Next, moving further, another question related to mole concept. Here it is given as 11.2 liters of ideal gas. 11.2 liters of ideal gas at 0 degrees Celsius and 1 atm. 0 degrees Celsius and 1 atm. So here they mention like STP or NTP conditions. They gave information about STP or NTP conditions because NTP, STP almost same. Almost same. So here you can consider now these conditions. Here it has STP. STP conditions. So here the number of moles is equal to given volume how much? 11.2 by 22.4 liters. 1 mole of any gas at STP conditions. So same I am writing here 22.4 liters. So then here it is equal to 0.5 moles. 0.5 moles. Straight away back to back easy questions. Next, moving further. Moving for further calculations here. See. Here they are asking about find number of protons. Find number of protons in 180 ml of H2O and density of water also given here. Density of water given is equal to 1 gram per ml. We need to find number of protons in 180 ml H2O, density of H2O given 1 gram per ml. See here density we know and volume known, but here we don't know mass. We don't know mass, so how to calculate mass? Here we know mass is equal to density into volume, where density is 1, volume is 180, so which is equal to 180 grams. 180 grams. Now first you calculate moles of water before going for number of protons. Number of moles how we calculate? Given mass by molecular mass. Given mass is 180, molecular mass is 18, overall it is 10 moles. Once if you know the moles of the given substance, then we can proceed for calculation of number of protons. The key point is 1 mole of water, 1 mole of H2O, or you take 1 molecule of H2O. 1 molecule of H2O contains how many protons? How we calculate protons? Protons are equal to atomic number. 1 mole of H2O here contains 2 into 1 hydrogen, atomic number 1, so 2 hydrogens plus 1 into 8, atomic number 8, so overall here 10 moles of protons. Here you may get doubt how we are getting 10 moles of protons. 1 molecule of H2O contains 10 protons. 1 molecule of H2O contains 10 protons, but 1 mole of H2O contains 10 moles of protons. I think it is clear to everyone. 1 molecule of H2O contains how many protons? Contains 10 protons. But if I take such 1 mole molecules, then 10 into mole we write. That is nothing but 10 moles of protons. Hence, 10 moles of water, 10 moles of H2O contains, 10 moles of H2O contains, what we specify? 10 moles here. So each having 10 moles of protons. So 10 into 10. So here it is 100 moles of protons. 100 moles of protons. 100 moles of protons. So which is equal to? 100 moles meaning how many? 100 into 6.022 into 10 power 23 protons is the answer. Why? 100 moles of protons meaning 100 into 1 mole. Overall answer here we specified. Next moving further, once revisit the question. Next moving further, I am taking here 2 moles of CaCO3. 2 moles of CaCO3. I am writing few statements here. 2 moles of CaCO3 contains, I am writing one statement here. It contains 2 into Avogadro number of CaCO3 molecules. Is statement correct? Of course, because 2 moles of CaCO3 contains 2 into Na number of CaCO3 molecules. Perfectly correct. 2 moles of CaCO3 contains, I am writing like this, 5 into Na number of atoms. How? Here previously they specified about molecules. So CaCO3 entire molecules we consider, but here atoms they mention. How many atoms in CaCO3? 1 calcium, 1 carbon, 3 oxygen, overall 5. So 1 mole contains 5 moles of atoms, but here 2 moles contains, if 1 mole contains 5 moles of atoms, 2 moles contain 10 moles of atoms, but here what they mention? 5 into Na number of atoms. Incorrect. So which is correct here? See, it is correct answer for 1 mole of CaCO3. But here you see 5 into Na number of atoms, it is valid for 1 mole of CaCO3, but not for 2 moles of CaCO3. For that, which is correct statement? Here it is having 10 into Na number of atoms. So here it is correct statement for this. Still further, if I consider next statement based on this, I am writing here 6 gram atoms. 6 gram atoms of oxygen. See here, it twisted 6 gram atoms of oxygen. Gram atoms meaning is mole atoms. Remember, gram atoms meaning mole atoms. Once you revisit, last time I gave the 3 terms which JEE likes more. From those 3 terms, one of the terms I used here under the solution statement. 2 moles of CaCO3 contains 6 gram atoms of oxygen. Right or wrong? Let us see now. 1 mole of CaCO3 contains 3 moles of oxygen atoms. 1 mole of CaCO3 contains 3 moles of oxygen atoms. Here you can see. But here 2 moles given. If 2 moles given, 1 mole contains 3 moles of oxygen atoms. 2 moles given, automatically it is equal to 6 moles of oxygen atoms. See, gram atoms, how you can write? 6 mole atoms of oxygen. Both are same. So hence both are correct. Anyway, you can specify. Okay. Then next statement. I am writing here 2 gram atoms. See, sometimes even if they give like this shortcut G atoms, carbon. See, 2 moles of CaCO3 contains, see, 1 mole of CaCO3 contains 1 mole of carbon. 2 moles of CaCO3 contains 2 moles of carbon. Instead of writing 2 moles of carbon atoms, I am writing 2 gram atoms of carbon. Or you can write 2 moles of carbon atoms. 2 moles of atoms of carbon. So here both are correct statements. Such type of questions mainly confuse students. You need to observe it properly without any doubt. Next moving further. Next question. See next question. Here a gaseous mixture contains gaseous mixture of H2 and NH3 gas contains 68%, or you can say 68% is 68% by mass of NH3, and the vapor density also given in question VD, vapor density of the gas. A gaseous mixture of H2 and NH3 gas contains 68% by mass of NH3 and vapor density of mixture is dash. They are asking here. Observe question carefully, everyone. A gaseous mixture of H2 and NH3 gas contains percentage 68 by mass of NH3. The vapor density of the mixture is dash. So how we need to do? First, percentage by mass given 68 grams out of 100, 68 grams is NH3. So now see here. I am calculating first number of moles of NH3. Because 68% by mass meaning out of 100 grams, 68 grams is NH3. Remaining is H2. And molecular weight of NH3 is 17, 14 nitrogen, 3 hydrogen, which is 4. Similarly, if 68 grams is ammonia, then remaining number of moles of H2, if I take 100 grams mixture, that is remaining is 32 by, see, H2 meaning that is 2, overall molecular weight is 16. So now vapor density of the mixture, how we calculate? First we should know mixture molecular mass. So molar mass of the mixture, is equal to total mass by total moles. Molar mass of the mixture meaning here you can write it as average mixture mass, average molar mass. Both are correct. So total mass how much? We know it is overall 100. And here total moles. Total mass of the mixture, total moles here it is. So total moles how many? 4 plus 16. Overall here around it is 5. Now come to the vapor density. Vapor density how we write? Vapor density is molar mass of the mixture by 2, because molecular mass or molar mass by 2 we know, which is equal to 5 by 2, which is unitless. 2.5 is answer for this given question. Is it clear? Next moving further. Next question. Once look into this question, vapor density how we calculated. Observe it. Next, molecular mass of compound is 75. Molecular mass of compound, here you can see molecular mass of compound is 75. If it is 75, then how to calculate? Then you can mention here, calculate the mass of 100 molecules. calculate the mass of 100 molecules in AMU. So here the molecular mass of compound is 75. Then we need to find the mass of 100 molecules in AMU. See, molecular mass meaning how we specify? It is 75 AMU because molecular mass we specify in AMU. Gram molecular mass is in grams. See the question. Molecular mass meaning, one should be very clear about here. Molecular mass meaning, that is mass of one molecule. Mass of one molecule in AMU. So how we consider? Which is equal to 75 AMU. Here they are asking about 100, mass of 100 molecules. If one molecule mass is 75 AMU, then mass of 100 molecules. Mass of 100 molecules is equal to, here you can specify 75 into 100, which is 7500 AMU. So it is answer for 7500, that is AMU. Again, most important question. Looks like very simple question. These are the conditions or situations where most of the students make mistakes. So that if you once properly go through this question format, and in future you are not going to do any mistakes, with more confidence you can attempt JEE Mains as well as advanced questions. Basics are more important. Sometimes even in JEE Advanced, basic oriented statements framed. You should be clear about those terms. Next, last question. Last question. Here atomic mass is given. Atomic mass is given, two isotopes given. In these two isotopes, whatever isotopes given here, isotope 1 having molecular mass 37, isotope 2 having molecular mass 35. You can say it is mass. And their percentage abundance also given. It is known question, most important question. Here it is given for 75% given, 25% given. The question is calculate average atomic mass. Calculate average atomic mass. Already we used same question format. We discussed formula in previous lecture. See, whatever formulas required in this lecture too, we already did discussion in lecture 1. If you did not watch the lecture 1, once you revisit lecture 1, we'll come back to lecture 2. So here average atomic mass I am representing like this. So how we calculate? The mass of isotope 1 37, percentage abundance of isotope 1 25, plus mass of isotope 2 35, percentage 75. By total abundance we know 75 plus 25 100. So here if you calculate here, once everyone calculate the given information, how much you will get? See once. Here you get 35.5. So average atomic mass we mention only in AMU. It's not gram atomic mass. AMU is answer. I hope everyone followed the questions without any doubt. If you face any difficulties in solving these questions, properly go through lecture 1 with more confidence. Easily you can attempt these questions. So till now, in these two lectures, basic fundamental terms and basic calculations we completed. With these applications, we are moving further into next upcoming lecture, that is concentration terms. Until then, once again, you go through these questions. If any doubts, get back into lecture number 3. There we'll discuss further with connected applications. Thank you very much. Thank you for your patient listening. Thank you.